about the zeros of polynomials. We have already been dealing with zeros of polynomials, so this should not be something that is brand new. What we're doing is we're adding ways that we can find these zeros when things don't factor nicely. That's what we have to find. So, and some of you just aren't great at factoring. So if we can use our rules of division, if we can use some tools that we have to find those. And so far, we've only been dealing with polynomials that have a power of 3 or 4 at the most. And some polynomials might have very high, much higher powers than that. So we're going to start off. I've broken it into 3 parts that we'll do a little bit today and tomorrow and the next day. So let's talk about the remainder theorem. So what's really interesting is if x minus k divides into our polynomial, then the remainder has to be f of k. If x minus k divides into our polynomial, then f of k is going to be the remainder. Think about that. That's really weird. So if we are dividing by x minus 2, the remainder is always going to be the function value at 2. Now, why is that helpful and why is that important? Well, the reason it can be helpful and very important is the fact that if we get a remainder of 0, what do we know? It can divide into it. We can take it out. So it works nicely. So it's just a tool to allow us to quickly tell if something is divisible by a certain quantity. And it's all about that 0. Remember that 0 value. So if f of x was divided by x minus k, then the remainder is always f of k. So example, if we wanted to divide by x minus 2, and we just wanted to go, hey, I wonder what our remainder is going to be. Well, it's just stick 2 into the function. You'll find what your remainder would be in that division, which is really kind of interesting. So let's look at an example. It says use the remainder theorem to find p of 2, and then we're going to divide to verify that what we found is right. So first, let's just practice. Let's just stick a value of 2 in. Let's see what we got. Don't make that harder than it is. It's just we know how to stick values into a function. We've been doing that all year long. So that's just going to be 16 minus 16 minus 16. A lot of 16s. Let's just make sure. Yep, plus 3, which is negative 13. So that's negative 13. Now, let's actually do the division and let's check. Do we really get a remainder of negative 13? So because this is a perfect candidate for synthetic division, that's what I'm going to use. But here, let me show you. It says specifically, give the quotient and remainder for the associated division. Now let's talk about what the associated division is. You're just going to take x minus that number. So x minus 2. So that is the associated division. It's always going to be x minus the input, whatever that input is, in this case 2. So when we do synthetic division, what goes in that corner? The solution to x minus 2 equals 0. 2. So they all should go together, okay? So we should see 2 in that corner. Now let's take a look at our polynomial here for a moment. Our powers go 4, 3, 2. Something's missing. What's missing? 0. The x term. There's a 0 there. So when we go to write down the coefficients, that's the coefficient on 4, on 3, on 2, on x to the first. There is 0x to the first, and then a 3. So I'm just going to set up my synthetic division box. Okay, so let me go over it one more time. These are the numbers from the factor, our input of the function plugging in. These are our coefficients. They have to go in descending order. If any power is missing, put a 0. So fourth, third, second, no x's, and then the plain old number goes here. Okay, this spot is going to be our remainder. What do we know our remainder is? Negative 13. So we actually can fill that in, and that's a great way to check our work. Okay, so let's go. So remember how you do this. We multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. I don't know why I switched color there, but multiply, write it down, add them up. Do we get negative 13? Yes, we do. So they should all go together. All that information goes together. So what is our quotient? Well, our quotient is right here. You got to put your x's back on. Our highest power before was 4. Just take it down one level. So it becomes a cube. So it's x cubed plus 0x squared minus 4x minus 8 is our quotient. I don't need to put that, sorry. So our quotient is x cubed minus 4x minus 8. I would assume that you don't have to put the 0 terms for Alex, but if you get it wrong and there was a 0 there, you might want to put it. But that's our quotient. Our remainder is negative 13. If we did it right, those things should always match. Does anybody have any questions about that example? Okay. Now let's look at question number 6. It says, use the factor theorem to determine whether x plus 3 is a factor. Specifically, evaluate p at the proper value and then determine whether x plus 3 is a factor. Well, the proper value they're talking about is the 0 associated with x plus 3. So where does x plus 3 equal 0? So that's what we're checking. If I input negative 3, do I get 0? So if I input negative 3 into my function, do I get 0? That's what we're checking for. If I get 0, it's a factor. If I don't get 0, it's not. So let's plug in negative 3 into our function. So that's going to be negative 2 times negative 27 minus 4 times 9 minus 18. That's a heck of a lot of minuses there. Even, oh, maybe not. Oh, because that part's positive. Oh, it might work. It might work. Let's check. Okay. I was jumping to conclusions there. That's 54 minus 36 minus 18. Oh, it does give us 0. Yeah, be careful with your signs. Those two negatives made a positive. And so it is a factor. So we say p of negative 3 is equal to 0. So x plus 3 is a factor. If we get any other value besides 0, the answer would have been the bottom one instead of the top one. So it is a factor if when we plug in its associated 0, if we get 0, we're good. If we get any other number, nope, not so good. Okay. Everybody get that one? Okay. So that leads us to the factor theorem. If k is a 0 of f of x, then x minus k is a factor. Or if x minus k is a factor, then k is a 0. So that if and only if in mathematics means that both facts work with each other back and forth. So if you have the one fact, k is a 0, x minus k is a factor. If you have the fact x minus k is a factor, then k is a 0. So that if and only if means they both have to work in conjunction with one another. Okay. So if you want to factor out a polynomial and it doesn't look clearly like it's something that's factorable, if you know that f of k is a 0, then divide out x minus k. You know it's in there. You know it's hiding in plain sight. And then what's left might be something smaller that is factorable, that you can see a little clearer. And then you keep doing that until you have reduced it as much as possible. So this tool just really is going to allow us to check some things and find some factors that actually work. Okay. So let's look at question 8. It says, for the polynomial below, 3 is a 0. So you should immediately think to yourself, that means that f of 3 equals 0 and x minus 3 is a factor. So that fact right there, the fact that 3 is a 0, means that if I plug 3 in, I get 0, and that x minus 3 divides into it evenly. And then it says to express f of x as a product of linear factors. This means factor down as far as possible. That's what that means. Okay. So what we're going to do is we are going to factor out the x minus 3 we know that's hiding. Now you can do x minus 3 into f of x. You can do long division. But if I have the opportunity to use synthetic division instead, I do tend to go with the synthetic division. Okay. So I'm going to put 3 in the corner. I'm going to check my powers. 3, 2, 1, nothing. Perfect. So I'm going to go 1, negative 7, 14, negative 6. I'm going to set up my box. So if you like long division, you can just do the long division. I'm not going to. If I have the opportunity to use synthetic, I do tend to use synthetic. Okay. So we're going to multiply, write it down, add them up. Multiply, write it down, add them up. What should our remainder end up being? What should our remainder end up being? Our remainder, since 3 is a 0, it better be 0. Okay. So 3 times 2, multiply, write it down, add them up. Guess what we got? That's what we should have got. Okay. So this is what we know so far. If we take out an x minus 3, we are left with x squared minus 4x plus 2. Okay? Now, here's what you have to get wrapped around your brain. X squared minus 4x plus 2 is always able to be broken apart, even if you can't factor it, by the formula that's up on the board, the quadratic formula. We can always use the quadratic formula to break it up. Okay. Now remember, it's always going to be, now if the highest power was 3, we can break it up to be x minus the 0 times x minus the 0 times x minus the 0. Now we already have one of them, x minus 3. But let's find how this breaks up. So we need to break up x squared minus 4x plus 2. Now x squared minus 4x plus 2 is not factorable in the sense that we know it. But let's solve that using the quadratic formula. So let's break that apart with the quadratic formula. So we get negative b plus or minus the square root of b squared minus 4 times a times c all over 2a's. And then if you have any square roots that show up, we have square root of 8. The square root of 8, since 8 is 4 times 2, is 2 radical 2. So let's make that 4 plus or minus 2 radical 2 over 2. Now, are both the thing in front of the plus or minus symbol and the thing in back of the plus or minus symbol, are they both divisible by 2? Sure. So you want to do that division, only if they're both divisible by 2. So our factors, or our zeros, are 2 plus or minus square root of 2. Now let's actually make them 2 separate things. 2 plus the square root of 2, 2 minus the square root of 2. Because we need to put those into there. Okay, now this is the weird part. See how it's minus the 0, minus the 0? How do we minus those things? Well, to minus an expression, we add the opposite of both the things we plug in. Okay, so now let's keep that in mind. The final answer that Alex wants is x minus 3 was our first one. X, now, if we subtract 2 plus the square root of 2, we have to change both those signs. So it's going to be negative 2 minus the square root of 2. Yes?
Would it be 4 plus or minus 4 square root of 2, square root of 8, actually square root of 16?
You have to subtract first.
Okay.
Yeah, there you go. That's okay. Okay. So, and then we're going to subtract the second one. Now, to subtract this one, that has to become a minus, but that has to become a plus. Change every sign. And so it's going to be minus 2 plus square root of 2. These two things here are called conjugates. They are conjugates if you notice the square root is the thing that changed. The square root is the thing that changed. So that is our answer. That is what Alex is looking for. See this word linear factors? See how all of our x's are to the first power? There's no powers. They don't want any powers on any of your factors. They just want them to say x minus the 0, x minus the 0, x minus the 0. So they gave us that one. The division said, hey, we have a quadratic, and you can always use a quadratic formula for that. And then it's always x minus the 0, x minus the 0. So it's kind of a strange technique, but that unfortunately is the way it goes. So if your quadratic doesn't factor, got to use the quadratic formula. Now, if we get i's, there are, I would assume they want us to just leave the i's alone. But if you get to Alex in that part and there's an I in your answer, let me know. I'd like to know what they're looking for, okay? So that's kind of strange. Yes? It didn't make it any better, but and you may have done ones like this in Algebra 2. Depends on your teacher, how far you got and what your year was like last year. Okay. Now, let's take a look at your homework. So 6, 7, 8, and 9, it says, use the remainder theorem to find the remainder. You do not have to do the whole division. That is not what they're checking for. You can do it. Feel free, go for it. You can do the division to find the remainder. But what you're going to do is you're going to think about, where is x minus 2 equal to 0? Well, that's at 2. And so if this is our f of x, we're just going to find f of 2. Just plug 2 in. That will be your remainder. That is your remainder. Okay, so that is all. So number 8, you're going to have to stick in what number? What number? -1. So that's all you're doing. And this is where you're sticking it. That's your f of x. Okay, so that's all you're doing for the top. You're just finding the remainder using that remainder theorem. Okay, now the bottom is just like that last example we had done. Okay, you are going to divide out x minus 1. They've told us that x minus 1 is a factor. So you can take it out using long division or synthetic division. You'll be left with the quadratic. Try to see if that's a factorable quadratic. And if it's a factorable quadratic, you can then factor it, and then you'll get 3 pieces. And that's how you would find all the zeros. So let me give you an example. So let's look at 14 together before we stop here. So we know that x minus 1 is a 0 at 1. Okay, so it would hit the x-axis at 1. So I'm going to do synthetic division to 14's problem. So you'll notice, check your powers. 3, 2, 1 number. And so you're going to take out those coefficients, and we're going to set up our division box. So we're going to multiply, write it down, add them up, multiply, write it down. I sure did not do that part right. Just multiply, write it down, add them up, multiply, write it down. We know that better be 0. If it's a factor and they are giving you the fact that that's a factor, you better get a 0 in that corner. And then write your quadratic. Now, odds are your quadratic should be factorable. Odds are your quadratic should be factorable. And if not, you got to use a quadratic formula. Remember, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. It does factor however you want to do it. It factors to be what you see here, 2x minus 3 and x minus 2. So we know that our function for number 14 can be broken down to be x minus 1, 2x minus 3, and x minus 2. Now they said to find all the zeros, to find all the zeros. So the zeros happen when x is 1, when x is, if you solve that one, it would be 3 over 2, and when x is 2. So I want you to break it down into its linear factorization, this factored form, and then I want you to show me the zeros. Okay? So that is the assignment. Yeah. Do you want to see the top? Right there? Okay.